scheme. So you see we have two competing theories. One look at the Hoyle state as simply a spherical state with vibrational excitation of the 3 alpha particle, and the Coulomb and Baer actually predicted to be a deformed 2+, and this would be, the 2+ second will be part of the rotational band built on top of it. And here you go. They added the state that they predicted into the compilation of the triple alpha burning rate, and this is the one which was Fowler and Kakelan compiled in 1988. Essentially, all of this is coming from one state, from the Hoyle state. Okay, so in Red Giant, we produce carbon-12 at around 200 million degree Kelvin. In core collapse, where you have the collapse of the core, you have a lot of alpha particles. You also have a lot of neutrons. So over here at a much larger temperature at 3 gigakelvin, they predicted a very large enhancement on the carbon-12 production. This is very important because if you take all the 3 alpha particles who make carbon-12, there are less alpha particles to make alpha plus neutron to make beryllium-9. That means that there is more neutron to make the R process. So this is a major issue in the core collapse, and any increase certainly by a factor of 10 is major, but even by a factor of 2 is major, and we need to check that is correct. So the experimental problem. Here's the beta decay, and essentially the beta decay of nitrogen-12 and boron-12. We see the 1+ state, we see the Hoyle state, and essentially we just see 1 0+ third. One state. There is no evidence, according to them, to any 2+ state. On the other hand, if you look at the alpha pi, this is the data from Japan. Yeah, again, you see this 0+, the broad 0+, 3 MeV, a broad 0+, you see the 3-. And if you dig very, very deep into the data, you might see over here a 2+. Okay? So after you subtract all the known states, they claim that there is a 2+ which is buried under all the states over here. Well, the same thing was done in Itamba, in carbon-12 pp'. Again, there is a major, this is a logarithmic scale, there is a major background from the 0+ third, and if you remove all the known state, then there is a little bit left over, and that's a 2+ second. Well, we did an experiment at Yale, perhaps the last experiment that was done at Yale on the tandem, and again, in our data, if you remove all the state, you are left with a 2+. And that is basically the problem that we are facing. So both beta decay experiment and carbon-12 pp' experiment, they are plagued by a background from the 0+ third. So in physics, there are two points of view. You either subtract the background or you get rid of it. I like to get rid of it. And the way to get rid of it is by choosing the right probe. If you have a gamma beam, clearly a gamma beam cannot give you a 0+ to 0+ transition. So therefore, you remove the background and you have background-free, clean spectrum, and hopefully with gamma beam, you will be able to resolve this controversy concerning the existence of the 2+ second in carbon-12. Again, the importance of this state in astrophysics cannot be underestimated. Astrophysics is one of these cases that one state in the right location can change the whole scenario, so it's important to put a lot of effort into resolving this. So we started a new project at Duke University, a tunnel with the Higgs, which I will show you. We built a new detector, we put it on the beam line, and let me tell you first about the facility. So the facility used about 1 GeV electron that runs in